Hello students, welcome to Sankalp learning classes. Let us start KCET questions on relations and functions. First question, let R be the set of points inside a rectangle of sides A and B, A, B greater than 1 with two sides along the positive directions of x-axis and y-axis. Let us take rectangle ABCD and PXY be any point which is inside the rectangle. Okay, and this you can extend as x-axis. Similarly, this you can extend as y-axis. Okay, and this will be the point 0, 0. Okay, clearly this distance is less than A. Similarly, see if you take perpendicular, it will come here. So this distance is less than B. So it is this distance is greater than 0. So you can write 0 less than x less than A. Similarly, you can write 0 less than y less than B. Okay, now let us check the options. The option A, R is equal to x comma y such that 0 less than or equal to x less than or equal to A, 0 less than or equal to y less than or equal to B. So since x cannot be 0, so you can discard the first option, option A. Now check option B. Option B also 0 less than or equal to x less than or equal to less than A, 0 less than or equal to y less than B. So x cannot be 0, so you can directly discard option B also. Okay. So similarly here also 0 less than or equal to x. You can directly discard this. Now check option D. R is equal to x comma y such that 0 less than x less than A, 0 less than y less than B. So the last option, option D is the correct option. Option D, R is equal to x comma y such that 0 less than x less than A, 0 less than y less than B. That is the correct option. Thank you. Hi students, let us take this question. Let T be the set of all triangles in the Euclidean plane and let a relation R on T be defined as ARB if A is congruent to B for all AB belongs to T. Okay, so let us take triangles, triangle ABC, triangle DEF, and triangle PQR. Okay, what do you mean by congruent triangles? Congruent triangles, triangles you should have. So suppose triangle ABC and triangle PQR, they are congruent. What do you mean by that? So corresponding angles of ABC and the sides of ABC are equal to corresponding angles and sides of PQR. If you take these two triangles as congruent, then this angle must be equal to this angle must be equal to this, and this angle must be equal to this. Similarly, this side must be equal to this side must be equal to this, and this side must be equal to this. Then these two triangles are congruent. Clearly, triangle ABC is congruent to itself. ABC is congruent to triangle ABC. This implies R is reflexive. What is the definition of reflexive relation? For all A belongs to AA must be in R. So triangle ABC is congruent to triangle ABC. This is AA. So R is reflexive. Suppose triangle ABC is congruent to triangle DEF. That means corresponding angles and sides of ABC equal to corresponding angles and sides of DEF. If you take the reverse, if you take ulta, then also it will be congruent. Triangle DEF is congruent to triangle ABC. Correct? So corresponding sides and angles of DEF are equal to corresponding sides and angles of ABC. This implies R is symmetric. R is symmetric because what is the definition of symmetric relation? If AB belongs to R, implies BA belongs to R, then it is symmetric. In this case, this triangle ABC is A, this is B, AB belongs to R. Take ulta, BA, this also belongs to R. Correct? Therefore, R is symmetric. Got it? Next, take three triangles. Triangle ABC congruent to triangle DEF, triangle DEF is congruent to triangle PQR. So corresponding sides and angles of ABC are equal to corresponding sides and angles of DEF. Corresponding sides and angles of DEF are equal to corresponding sides and angles of PQR. That implies corresponding sides and angles of triangle ABC must be equal to corresponding sides and angles of PQR. Therefore, triangle ABC is congruent to triangle PQR. Implies R is transitive. R is transitive. What's the definition of transitive? AB and BC belongs to R. These two must be same. Therefore, we have taken this and this same. Then this implies AC belongs to R. Okay. So then triangle ABC is congruent to triangle PQR. Therefore, R is transitive. We have proved R is reflexive, R is symmetric, and R is transitive. Any relation which is reflexive, symmetric, and transitive, then it is called equivalence relation. Now let us take option. First option, reflexive but not transitive. But we have proved R is transitive. Reflexive but not transitive. Since we have proved R is transitive, you can directly discard A. Transitive but not symmetric. But we have proved R is symmetric. Third option, equivalence relation. Since R is reflexive, symmetric, and transitive, it is an equivalence relation. Therefore, option C is correct. So, the final answer is option C, equivalence relation. Thank you. Hi students, let us take the question. If a relation R on the set 1, 2, 3 be defined by R is equal to 1, 2, then you need to check R is reflexive, transitive, symmetric, or an equivalence relation. Okay. So what is given? The set is A is equal to 1, 2, 3. This is given, and R is 1, 2. There is only one element in R. It's only one element in R. R to be reflexive. R to be reflexive. For all A belongs to R. That is the definition. Here also we have. For all A belongs to R. That means here A can be 1, 2, 3. So to be reflexive, 1, 1, 2, 2, 3, 3 should be there in R. But none of the elements, these three elements, is in R. So 1, 1, you can directly write 1, 1 does not belong to 1, 1 does not belong to R, implies R is not reflexive. Okay, so you can discard the first option, reflexive. Next, 1, 2 belongs to R, but 2, 1 does not belong to R. This implies R is not symmetric. R is not symmetric. Because what's the definition of symmetric relation? For all AB belongs to R, BA should be there in R. But in this case, we don't have 2, 1. We have 1, 2 belongs to R, but 2, 1 does not belong to R. Therefore, R is not symmetric. So option C is also not correct. Next, check transitivity. How do you check transitivity? What is the definition of transitivity? What is the definition of transitivity? AB belongs to R and BC belongs to R. This should imply AC belongs to R. But we don't have such pairs, this type of pairs in R. We have only one pair. In such cases, you can assume that R is transitive. R is transitive. Since we don't have such pairs, you can assume this R is transitive. So option B, R is transitive, is the correct option. So answer is option B, R is transitive. Thank you. Hi students, let us take the question. Let A is equal to 1, 2, 3 and consider the relation R is equal to 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 1, 3. Then you need to check R is reflexive, symmetric or transitive or an equivalence. Okay. So given the relation R contains 1, 1, 2, 2, 3, 3. See, for all A belongs to, see the definition of reflexive. For all A belongs to R. In this case, this is true because 1, 1, 2, 2, 3, 3 belongs to R. 1, 1, 2, 2, 3, 3, all elements are there in R. Implies R is reflexive. R is reflexive. Now, 1 2 belongs to R, but 2 1 does not belong to R. This implies R is not symmetric. Okay? R is not symmetric. Next. One, two belongs to R. 2, 3 belongs to R. This implies 1, 3 also belong to 1, 3 also belongs to R. So, with respect to these two pair, it is transitive. Let us search such pairs. So 1, 1, 1, 3. These two belong to R. That implies 1, 3 is also there in R. So it is transitive with respect to these two pair also. Any other? 2, 3. 3, 3. This implies 2, 3 also belongs to R. So it is transitive. One more. 1, 3, 3, 3. You need to check all such pairs for transitivity. So this implies you need to remove this and take the rest 1, 3. So we checked all the pairs, so it is transitive. Therefore, this implies R is transitive. Now check the options. R is reflexive, we have proved, but not symmetric. That also we have proved. So the first option is correct. You need not have to check for the second and third and fourth, but still we will check. R is reflexive but not transitive, but we have proved it is transitive, so it is wrong. Symmetric and transitive, but R is not symmetric, therefore it is not true. Neither symmetric nor transitive. It is not symmetric, but it is transitive. So the last option is also wrong. Therefore, the final answer, option A, R is reflexive but not symmetric. Thank you. Hello, students. Let us take the question. Let R be an equivalence relation defined on a set containing 6 elements. The minimum number of ordered pairs that R should contain is option A 36, option B 64, option C 6, option D 12. So what is given here? R is an equivalence relation. So R is equivalence relation means R is symmetric, reflexive, and R is transitive. Okay. There are 6 elements in the set. Let us take that set as A. Okay. Assume the 6 elements as 1, 2, 3, 4, 5, 6. It can be any. Let us take this. Now, to be an equivalence relation, R should be reflexive, correct? So, let us take the elements which satisfy reflexive property. So, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Okay. So, to be reflexive, R should contain 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Okay. Now, to be symmetric, AB should be there in R. That implies BA should be there in R. So, if you reverse any of these elements, that will be the same element. So, R is symmetric. So, we have seen already, if we don't have the pairs like AB, BC in R, then we can assume that as transitive relation. So we need not have to consider any other elements. This relation R is reflexive, symmetric, and transitive. Hence, it is an equivalence relation. How many elements? 1, 2, 3, 4, 5, 6 elements. So there are 6 elements in R. So minimum number of elements must be 6. You can add some more elements, still it will be an equivalence relation. But this is the minimum requirement. So if you have 6 elements in the set A, relation to be an equivalence relation, you should have minimum 6 elements. So check the option. Option C, 6 is the correct answer. So final answer is option C, 6 is the correct answer. Okay, thank you. Hello students, let us take the question. Define a relation R on A is equal to 1, 2, 3, 4 as X R Y if X divides Y. Okay, so the relation is X divides Y and the set A is equal to 1, 2, 3, 4. Okay, and you need to write the relation. So R is equal to, so what it says, X divides Y. So take all possible permutations. 1, let me take first element 1. So if you take next element also 1, it divides 1, 2, it divides, 1 divides 2, 1, 3, it divides 1, 4. Okay, so we covered all the combination with 1. Next, 2. 2 divides, no, 2 divides 4 and 2 divides 2. Any other possibility with 2? No. Similarly, 3. 3 divides 3. No other possibility. 4. 4 also 4. 4. This is the relation. Okay, you need to write first the relation in which form? Set builder or ruler? It is set builder form. To write all the elements. List out all the elements satisfying the relation. Then you check whether it is reflexive, symmetric, transitive or not. So 1, 1 belongs to R, 2, 2 belongs to R, 3, 3 belongs to R, 4, 4 belongs to R. So for all A belongs to R. Therefore, R is reflexive. R is reflexive. Okay. Next, 1, 2 belongs to R. But 2, 1 does not belong to R. This implies R is not symmetric. R is not symmetric. Now, transitive. 1, 3 belongs to R. 3, 3 belongs to R. This implies 1, 3 belongs to R. 1, 4, 4, 4. Again, it is true. 2, 4, 4, 4. That is also true. Any other possibility? 1, 2, 2, 2. That is also true. Any other possibility? Any other possibility? That's all right. So R is transit. Therefore, R is reflexive. R is not symmetric, but R is transitive. So option is option A, reflexive, transitive. That is correct. So option A, reflexive, transitive. That is the final answer. Got it right? Thank you. Hi students, let us consider the question. Consider the non-empty set consisting of children in a family and a relation R defined by A or B if A is brother of B. Then you need to check whether R is symmetric, reflexive, transitive or not. Okay. A cannot be brother of himself or himself. A cannot be brother of himself. So A or B is not true. A or A, of course. A or A is not true implies R is not reflexive. A cannot be brother of himself. Therefore, R is not reflexive. If A is brother of B, can B be brother of A? Sometimes it is possible. If B is male, then it is possible. If B is female, it is not possible. So to prove, you have to check for all possibilities. It should be true for all cases. But if B is girl, it is not possible. Therefore, R is not symmetric. R is not symmetric. Okay? If B is girl, then it is not possible. If B is boy, then it is possible. So to prove, you have to prove for all cases. Since we cannot prove, therefore it is not symmetric. Now, if A is brother of B, B is brother of C. See, B should be male because B is brother of C. Correct? Then can A or C? A is brother of C. Can A be brother of C? If C is girl also, then A can be brother of C. Therefore, R is transitive. Correct? A is brother of B. B should be male, and because B is brother of C. C can be male or female. But whatever the case, A is brother of C. Therefore, R is transitive. Okay? Therefore, check the options. Symmetric, it is not true. R is symmetric. No, R is not symmetric because P cannot be brother of A if B is girl. So this is wrong. Transitive but not symmetric. That is correct. Neither symmetric nor transitive, but it is transitive, not symmetric. Both symmetric and transitive. These two are wrong. Therefore, the final answer is answer B, transitive but not symmetric. Got it right? Thank you. Hi students, let us consider the question. Let us define a relation R on the set R of real numbers as A or B if A greater than or equal to B, Then R is, you need to check, symmetric, reflexive, transitive or equivalence. Okay. So the relation is defined. How relation is defined? It is A greater than or equal to B. See, A greater than or equal to A, because A is equal to A, implies R is reflexive. Correct? R is reflexive. Now, if A greater than or equal to B, can B greater than A? Suppose 2 greater than 1, then can 1 be greater than 2? Not possible. Therefore, this implies R is not symmetric. R is not symmetric. Okay? R is not symmetric. If A greater than or equal to B, B greater than or equal to C, then is it possible A greater than or equal to C? You take one example. 4 greater than or equal to 2, 2 greater than or equal to 1, then 4 greater than or equal to 1, correct? 4 greater than or equal to 4 greater than or equal to 1, correct? So R is transitive. Therefore, R is reflexive, not symmetric and transitive. So since it is not symmetric, it is not equivalence relation. Reflexive, transitive, but not symmetric. This is correct. Symmetric, it's wrong. Neither transitive, but it is transitive. Therefore, option B, reflexive, transitive, but not symmetric is the correct option. Okay. Hi students, let us consider the question. If f of x is equal to 2x plus 3, f is, you need to check whether it is 1, 1, on 2 or both or neither. Okay. To check 1, 1, you need to take two elements x1 and x2 and assume f of x1 is equal to f of x2 and prove x1 is equal to x2. So if you take 2x1 plus 3 is equal to 2x2 plus 3. This implies you can cancel 3, 3. 2x1 is equal to 2x2. So you can cancel 2 now. This implies x1 is equal to x2. You have taken f of x1 is equal to f of x2 and you have proved x1 is equal to x2. So this implies f is 1, 1. Okay. if f of x1 is equal to f of x2, if you prove x1 is equal to x2, then it is 1, 1. Got it? Next, to prove on 2, you take f of x is equal to 1. Okay? So, but f of x is given as 2x plus 3. Therefore, y is equal to 2x plus 3. Y is equal to 2x plus 3. Correct? Y is 2x plus 3. Then find x. X is equal to y minus 3 by 2. Correct? Y minus 3 by 2. So, for each y, you will have some x. For each image, you will have some pre-image x. Therefore, f is on 2. So, f is both 1, 1 and on 2. So, the option A is correct. Since it is on 2 also you can discard. Since it is 1, 1 also you can discard. So both are true, therefore you can discard. Therefore, final answer is F is both 1, 1 and on 2. Okay, thank you.